Another very useful tool, which we already saw, is the modulation. This is the multiplication of our signal with a periodic function, for instance, an exponential function. It can be written as the multiplication of our signal with an exponential function, where capital N denotes modulation. Observe that the modulation function here has a periodicity of 2 pi divided by capital omega n. Its z transform hence becomes this summation here, n going from 0 to infinity. We have our signal, we have the periodic function, this exponential, and then we have z to the power of minus n. Other important tool is the reversal of the ordering of a finite length signal sequence with length L, meaning x of n is non-zero only for n going from 0 to L minus 1. Let's define it here. So its z transform is this sum here. We can now reverse the order of the summation, of course without affecting the result, by starting at the highest index going to the lowest, replacing the index n by the expression L minus 1 minus L prime, index substitution. So here we have the index substitution and we have the reverse order of the summation. In short, it goes like this. So remember, the z transform was given by this, and now we have the reverse, which is given by this. So what we obtain is the inverse of the z in the z transform, which signifies the time reversal, and a factor of z to the power of minus L minus 1, which is simply a delay of L minus 1 samples. Important here is the inverse of z. What difference does this make in our Fourier spectrum? Replacing z by e to the power of j to the capital omega, we obtain x of minus capital omega instead of x of capital omega. For real valued signal, this only makes a difference for the phases of our frequency response. They are sign flipped because of the spectral symmetries for real valued signals. The magnitudes remains the same. This can still be of importance, for instance, in filter banks with aliasing cancellation. Here, the different signs also change the sign of the aliasing components, and that can make the difference between aliasing components cancelling between different bands or adding up. For complex value signals, the negative and positive frequencies can be completely different, and hence time reversal would make a bigger difference.